Hello everyone, you are welcome to my YouTube channel, The Don's Consult, where chemistry is simplified and learning made easy. Here, we bring chemistry topics that looks difficult and simplify it for proper understanding. We make chemistry look so simple. Today, we'll be discussing the chemical properties of alkanols. Chemical properties of alkanols, there are a couple of them, but I would like to discuss three. These three, I know that they are simple anyway, but they look somehow, will I say, confusing, or questions that used to come out from it looks somehow trickish. But with this lesson today, you are going to have a good understanding of it, and however question is fabricated from them, you will be having so much upper hand to answering them. Alright, let's go. Let's kick up. The first one I would like to discuss is the oxidation property of alkanol. The oxidation property, or it's oxidation process. Oxidation property of alkanol. Alright, you must understand that alkanol will oxidize, alright, to alkanoic acid. Alright, alkanol, pay attention to the intrigues. Alkanol will oxidize to what? To alkanoic acid. Alright, but listen up. And this is done by heating, just warm heating, by heating this alkanol with what? You can either use a very good oxidizing agent such as potassium tetraoxomanganate 7, or you can use potassium heptaoxodichromate 6. Potassium heptaoxodichromate 6. Okay, any of these oxidizing agents can be used. Now listen, when alkanol oxidize completely, complete oxidation, this sign is just to symbolize the oxidation. When there's complete oxidation of alkanol, complete oxidation of alkanol will take you to alkanoic acid. Alright, but if we have primary alkanol, alright, primary alkanol, and it is undergoing a partial oxidation, not complete one, partial oxidation, it will oxidize partially to what is called alkanal, and further oxidation will take it to alkanoic acid. Did you get that now? Complete oxidation of alkanol takes you to alkanoic acid. Alright, partial oxidation of primary alkanol will result to alkanal, and further oxidation will result to alkanoic acid. Alright, however, if we have secondary alkanol, partial oxidation of secondary alkanol will result to what is called alkanone. From your functional group, you should have the names of all this with you. Alright, and complete oxidation of the alkanone now takes you to where? To alkanoic acid. Let me give you a good example so I understand. Let's take ethanol, which has been a very good example to representing members of the alkanols. Alright, let's say we have ethanol. This is formula for ethanol. Okay, now ethanol oxidized, partial oxidation of ethanol, oxidized to form what? Ethanol will now form ethanol, because primary alkanol oxidizes to alkanal, so it will give you ethanal. This is ethanal. Alright, of course there it will liberate water. Okay, we are just putting that for you to understand. Now further oxidation of this alkanal will now form what? This ethanal. From ethanol it's oxidized to ethanal. That's partial oxidation. Now further oxidation of ethanal will form ethanoic acid. It's as simple as that. They can, questions can be fabricated with this. Okay, that's the first chemical property I would like to discuss. The second one is what is called esterification process, okay, or we say alkanols undergoing esterification process. What do I mean by that? That's what we call esterification process, esterification property, or you say process. All right, what do you mean? That is when you have alkanol. Mind you, I will only use the functional groups to explain it. This is the functional group of an alkanol. Of course, you know that, right? And it reacts with alkanoic acid. This is functional group for alkanoic acid. Either you call it alkanol, or you call it alkanoic acid, or you call it carboxylic acid. Okay, when you bring alkanol reacting it with alkanoic acid, of course it's a reversible reaction anyway, but let's just go to the what is it called now, the esterification process. You must know that this forward reaction now is the esterification process. What will it form? It will form what is called alkanoids, and this is the formula for alkanoid. This R here stands for number of, alkyl groups or aryl groups that may be attached, and of course there will be water. Okay, mind you, we are discussing the chemical properties of what? Alkanol. Okay, and this type of reaction is called condensation process. So when alkanol will react with alkanoic acid, and it will form alkanoid, or you call it ester. That's where the name esterification comes from, and liberate water. Let's give a very good example. Okay, let me give you a skeletal structure of this so that you can understand better. Look at this. Okay, this R stands for your what? Your alkyl group. All right, I will have a carbon atom that is bearing an OH here. Okay, and it reacts with another alkyl group that is bearing carboxylic acid with this OH. Now what happens to forming your ester? All right, now to forming your ester, you see this this H here, all right, we react with this H, we react with this OH here, okay, to form this H2O. Are you getting it now? Now this, to form H2O, this H from this alkanol and the OH from the oic acid will form your water, and of course this your R here, we have two this O, and of course I want to break it down. I can write it like this. You can have this, you can have this one here, then have your O, then have your R here. Okay, and this forms your ester. I don't know if you understand that. If you don't, just come to the comment section, put your question up, and I will explain better. All right, okay. Or if you want me to give you an example to how we can form that, I will quickly give you an example now. Okay, the example, let's have let's use methanol. This is CH3 here, CH3OH, that's your methanol. All right, and what can we use? Let's say ethanoic acid. Ethanoic acid is your ethanoic acid. Okay, when they react, I told you that the H from the ethanol will react with the OH here to form water. All right, okay. Now what happens? This your when you are writing it, it is the if you look at the skeletal structure that I put up here, the alkanoic acid will be written first. The alkanoic acid will be written first. So that will be, is now CH3, C and 1 O left. All right, and this alkanol will now come as the surface. All right, and when you are mind it will come as a reverse. The O will come here, and your, what's it called, your CH3 will now be here. Do you understand? But when you want to name the compound like this as an ester, you are going to name the alkanol first. What was the alkanol? Methanol. So methanol here now is no longer a methanol, it's now a methyl. So I will call it methyl because the O is off. A methyl, or you call it methyl, however you may want to pronounce it. And the ethanoic acid, you just remove the oic and add oit. So when you are naming it, you mention the alkanol first, and the suffix will come with from the alkanoid. So this will be methyl ethanoate. Methyl ethanoate. That is the ester formed here. That's the second chemical property of alkanols I would like to explain to you. All right, the third one, I told you I was giving you 3 today. The third one, very simple. That's the dehydration property of alkanol. Dehydration. And of course, from the word dehydration, you should know that there's a removal of what? Water content. All right, dehydration. So you have to understand that alkanol will dehydrate to ethene in the presence of a concentrated tetraoxosulfate 6 acid, and this is a very high exothermic reaction. All right, when an alkanol dehydrates, all right, in the presence of H2SO4, dehydrate in the presence of H2SO4, it will form an alkene, and there will be liberation of what? Water gas. All right, let's have a good example. We are still using ethanol as the family representative. Okay, all right, this is ethanol, C2H5OH. all right, in the presence of this concentrated H2SO4, ethanol will dehydrate to what? Ethene, to dehydrate to ethene, and water will be given off. All right, these are some of the chemical properties of alkanol I'll be sharing with you today. There are questions that can come with this. Maybe in the next video I will give you such question, then we'll solve it together so that you can be abreast and see how you can tackle some of these topics. If you have not subscribed, please subscribe. Okay, press that subscription button and give us a referral. Let's grow together. We are here to serve you better, making chemistry very simple. Thank you. See you in the next video. God bless you.